All right. All right, so this next section, they're talking about nth roots. You're wondering, what the heck did he just say? He said nth roots, like first, second, third, nth. Nth roots. We've dealt with square roots. We've also dealt with cube roots a little bit this year, okay? And we're just going to, quite a few examples, then we're going to dive into the assignment, okay? A lot of this is really, if you know your times tables, a lot of, and I'm not saying you know your times tables, I mean like clockwork. Like if I say, what's 3 times 6, and you go 3, 6, 9, 12, 15, 18, I know my times table. No, you don't. You know how to count by threes, which nothing wrong with that, but I mean, if you really know my clockwork, 7 times 8 is 56, 12 times 12 is 144, stuff like that. It makes this quite a bit easier. If you don't, you will struggle a little more in this, I will tell you, okay? But nth roots, now, I want to make sure, we're going to start with the ones that we already know, okay? And it's a little tricky at the very beginning, okay? If I was to give you this right here, square roots, okay? Square roots, we know means what do you times by itself twice to get that number? So, like if I gave you of 100, that's where I got to be careful. And you can use calculators if you need them. The calculator ain't going to give you all the answers, okay? Most students say, oh, the square root of 100 is 10. And they're not wrong. They're not wrong. Because 10 times 10 is 100. But you need to understand there's actually 2 square roots. The other square root is negative 10. Because negative 10 times negative 10 is also 100, okay? 100 has 2 square roots. If I asked you for 9's square root, you'd say 3 as well as negative 3. Because 3 times 3 is 9. And negative 3 times negative 3 is also 9, okay? Now, if I gave you something such as this, a lot of students say, oh, this is the square root symbol. It's kind of the square root symbol, kind of, okay? It's actually called a radical symbol, which is almost like a square. I mean, it's very similar to a square root symbol. And what I mean is this. If I ask you for radical 16 is 4, okay? Because 4 times 4 is 16. Is it also negative 4? No, it's not, okay? What you need to understand is the radical symbol, it said it's almost the square root. What it is it's the positive square root. The positive square, bless you. It's a positive square root of 16, which is 4. So on this one, the square root of 100 is 10 and negative 10. If I ask you for radical 100, it's only 10, bless you again. It's only 10. So the radical symbol is the positive square root, okay? Now, if I asked you for the square roots of negative 36, we learned in a previous section that there are no, and we're only dealing with real numbers in this chapter, okay? Something I don't think I told you guys yet is this. Are there imaginary numbers? Yes, there are, okay? But in any math class you ever take, you always assume that you're dealing with real numbers, unless they tell you otherwise, okay? A book or program or teacher will tell you whether they're dealing with imaginary numbers or not. So other than that, you always assume we're dealing with real numbers, okay? So the square roots of negative 36, again, some students think, well, the answer is negative 6. No, because negative 6 times negative 6 is positive 36. How do you times a number by itself and get a negative 36? You can't. There is no real square roots of negative 36, okay? There aren't any. Or if I gave you radical negative 25, there is no square. If you type in the square root of negative 25 on a calculator, it's going to give you an error, okay? I don't know what you're talking about. The calculator only deals with real numbers, okay? All right, so any question on square roots? Now we also have cube roots, okay? Cube roots. Students tend to struggle more with cube roots for a very simple reason. You've dealt with square roots for the last 2 or 3 years. Not every day, but the last 2 or 3 years in math classes, they've popped up from time to time. Cube roots you don't use nearly as much, okay? You just haven't yet, okay? Cube roots are not what you times by itself twice. It's what you times by itself 3 times. What do you times by itself 3 times to get that number, okay? Now, one other thing also is this. The way you say a cube root, like if I gave you this right here, this example, 8, the cube roots of 8. Now, I actually had a couple of virtual kids say on our test, there was a question you had to factor, like x cubed plus 8, I think it was, or something like that. And I had a couple of people write on their test, the 8 has no cube. There's no cube number times by itself 3 times to get 8. Yes, there is. 2. And some students go, well, that's 6. No, it's not. It's 2 times 2 times 2, okay? 2 times 2 is 4, times 2 is 8. So the cube root of 8 is 2. Now, here's where it starts to get a little tricky. Is it also negative 2? I heard somebody say no. I don't know who said it. Why? Why?
Because there's 3 negatives, so just go back to it'd be negative.
Right, negative 2 times negative 2 times negative 2 is not 8. It's what? It's negative 8. So it's only 2. It's only 2. Okay? What you need to understand is positive numbers have 2 square roots. Numbers that have cube roots, there's only one cube root, one real cube root. If I ask you for the cube root of 64. And again, this is where if you know your times tables, it works pretty nice, okay? Now, I'm going to give you a little clue here, okay? If you're not sure what it is, let's do some number theory here. What's an even number times an even number? An even number. What's an even times an even times an even times an even? An even. What's an odd times an odd? So if you multiply a bunch of odds, you're going to get an odd. You multiply a bunch of evens, you're going to get an even. So if I ask for the cube root of 64, could it possibly be 7?
No.
There's no way. You may not know what 7 times 7 times 7 is, but you should know that it's what kind of a number. It's an odd number, and that's an even number. So it might be 6, it's definitely not 5, it might be 4, it's definitely not 3. It's got to be some sort of even number. In this case, be careful, 8's the square root of 64. 8 times 8 is 64, but what do you times by itself 3 times? It actually would be 4. Little numbers get big pretty quick when you times them, other than 1. When you times by 1, nothing happens, okay? But 4 times 4 times 4 is 64. Now, how about this one? Negative 27. Can you have the cube root of negative? Back here we said you can't take the square root of negative 36. Can you take the cube root of negative 27? Actually, you can. Anybody know what you can times by itself 3 times to get negative 27? Careful, 3 is only 27. Negative 3. And that works because negative 3 times negative 3 times negative 3 is negative 27. So that's negative 3. All right? Now, you can use the radical symbol to express cube roots, okay? This is where it gets really tricky. I would just watch this next thing here, okay? If I give you this right here, there's a little 3, and you write it like that. Watch very carefully. I'll know on test day in 3 or 4 weeks, whenever we take our next test. I don't know when it's going to be. Who's paying attention, who's not. This 3, you don't write it like this. This is not penmanship class, lucky for me, okay? It's not a great big 3. It's like you put it up here. And that's the symbol for the cube root of 3, which is 2. And this is where it's going to get confusing. It's the positive cube root of 3. It's positive whenever possible. What I mean is this. Is this also negative 2? Is the cube root of 8 also negative 2? No. Okay, that would be negative 8. This right here would be the cube root of 64, which is 4. What if I give you this, the cube root of negative 64? What would that be? Any guesses? Not positive 4. Negative 4. Why?
Because it's not obvious.
Because negative 4 times negative 4 times negative 4 is negative 64. Okay. Is it also positive 4? No. 4 times 4 times 4 is positive 64. Okay. All right. So cube roots only have one answer. Okay. Only have one answer. All right. Now, one other thing also. A cube root is what you times by itself 3 times. That's why we have a little 3 right here. A square root is what you times by itself twice. You don't normally put it here, but you know what number you could put right here? What little number? A 2. You don't normally put it, but you can. I'm doing that for a reason, because later on you'll see. Okay, now, there's also fourth roots.
Oh, no.
It's not any harder. It's the same concept. Square roots, what do you times by itself twice to get that? Cube roots, what do you times by itself 3 times? Fourth roots, what do you times by itself 4 times? There's sixth roots, and we're going to deal with those, okay? So what do you times by itself 6 times to get that number, okay? So the symbol for fourth roots, if I was to give you 16, what number times itself 4 times? Be careful, it's not 4.
2.
Why? Because 2 times 2 times 2 times 2 is 16. Just 2? What else? Because negative 2 times negative 2 times negative 2 times negative 2 is positive 16. Now, the symbol would be fourth root of 16. Now, what would be the way I write it like that? What would that be? The way I wrote fourth root of 16 like that with a radical. What would that be? 2 and negative 2? Just 2. The radical symbol means the positive answer whenever possible. Whenever possible. What do I mean by whenever possible? How come this one wasn't positive
Doesn't have a zero.
because it's negative. It's, the cube root of that negative is a negative, okay? So this is positive whenever possible, okay? How about this one? How about the fourth root of 1? This one's so easy, some students struggle with it. What's the fourth root of 1?
One.
Why?
Because
Multiply what? 1
times 1
times 1 times 1 is 1. And negative 1?
No.
It's just 1. Now, if I ask you in words, what are the fourth roots of 1? You would say 1 as well as negative 1. But the radical symbol means the positive answer whenever possible. I'm going to say that again. Listen carefully. The radical symbol means the positive answer whenever possible. Whenever possible. Sometimes it can't be possible. Right here. If I asked you for the cube root of negative 125, any guesses of what I could times by itself 3 times to get negative 100? And a lot of students go like 40 something. Quit adding. We're not adding. Okay, 40 and 40 and 40 is 120. Little numbers get big pretty fast when you times them. What can I times by itself 3 times to get negative 125? Careful. Not 5, you're close. Negative 5. Because negative 5 times negative 5 times negative 5 is negative 125. Is it also positive 5?
No.
Because 5 times 5 times 5 is positive 125. And I don't want positive 125. I want negative 125. So this radical symbol is positive whenever possible, okay? We can even do fifth roots, okay? Now here's what we're going to do. We're going to start the assignment. Now we're not done. And I don't want to, I will tell you this, I don't want to rush through this, but I do want to get through as much of this today as possible so that tomorrow you can work. And I don't want to leave you guys hanging so that when you're having to work on this on your own on Wednesday, and I'm not here, or you're not here either, that you guys are stuck. Let's start through some of this stuff we haven't learned yet, and that's okay. We'll deal with it when we get to it. Okay, so let's actually start the assignment. All right. And it's not a super long assignment, but okay, number 5 we're starting on 5-1. I think there's only like 24 questions on this assignment. Let's see, where are we? 24, yep. Only 24. Okay, now it says identify everything in this chapter is real, not imaginary. We're not dealing with imaginary numbers, okay? Cube roots of 8. That's the question. What are the cube root? This says cube root or roots of 8. And we've already talked about this one. What do you times by itself 3 times to get 8? And negative 2? No, because negative 2 times negative 2 times negative 2 is negative 8. Okay? So the answer is 2, and that's it. Yes, ma'am?
So if it's an odd, like, cube or like, does it, like the negative, it won't have 2 answers?
It'll only have 1. Very good. I don't think I said that yet. Very good. And you said like cube root or fifth. Odd roots have 1 answer. Even roots have 2 or no answers. Because if it's a negative, if I ask for the even roots of negative 16, you can't, when you time an even number of negatives together, you're going to get positive. You're not going to get a negative. What she just said, great. Odd roots have 1 answer. Even roots have 2 or possibly no answers. Number 7. Okay, the real square root. This one's so easy, students struggle with it. Square root or roots of 0. And be careful, some students say, oh, there isn't one. Sure there is. What's the square root of 0?
0.
Why?
It's equal 0.
Because what equals 0?
0 times 0.
Equals 0. And negative 0?
No.
Because there's no such thing as negative 0. 0 is 0. Okay? So it's a 0. What are the cube roots of 0? 0. Because 0. Because why? Because what?
0, 0.
No, cube roots. 0 times 0. 3 of them. I need to hear 3 of them.
Still 0.
It is still 0, but I want to hear 3 of them. Okay. Number 9. Okay. Fifth roots. Okay. Fifth roots of negative 32. Fifth roots of negative 32. Now, if you can answer this, great. If not, listen carefully. We're taking a fifth roots of negative 32. Can we do that? Can we take the fifth root of a negative number? Can we do that? I want to hear somebody say, yes, you definitely can because, or no, you definitely can't because.
Yes, because it's odd.
What's odd?
The amount of times.
I want to hear you say the word. It's on the board. The what?
Root.
The root. The root is odd. You could take an odd root of a negative. You can't take an even root of, what's an even root of a negative?
Odd.
Huh? What's an even root of a negative number? We're not dealing with them in this chapter.
Oh, imaginary.
It's imaginary. We're not dealing with imaginary numbers in this one, okay? So, what number, and if you're not sure, again, some number theory here to help you out. If you struggle with your times tables, it's okay. Do you think we should try 3? 3 times 3 times 3 times 3 times 3, is that going to possibly be 32? There's no way it is. Why? What could you say about 3 times 3 times 3 times 3 times 3? What kind of a number? Odd. Okay, it's going to be an odd number. Okay, it's positive. Okay. So it's got, you want to, should we check 2? Perhaps 2?
Mm-hmm.
Okay. Maybe 4? Maybe 4. Let's try 2 first. It's quicker. What's 2 times 2 times 2 times 2 times 2? What's 2 times 2? 4 times 2. 8 times 2. 16 times 2 is?
33.
So is it 2? Careful.
Negative.
Negative 2. Okay, number 11. Okay. Bless you. All right. That is not 64 and 1/6. That is 64 to the 1/6 power. Okay? Now, this is stuff we've not talked about. Now, watch carefully. We're going to do a few more examples here. We're going to put this question on hold for a minute. Okay? Once you get this, this is a really quick, simple problem. Okay? I told you guys that, like, the cube root of 8 has a little 3 right there. Okay? Here's what you need to understand. Just watch this. And here's what I'm going to do about 4 or 5 examples. I want you to just watch them, and I'm going to give you a chance to copy them down if you want to, okay? So, 8 has an exponent right there. You just don't see it. It's a 1. So, the cube root of 8 to the first power, so do me a favor. This may sound really, really stupid. At the top of your paper, and I'm going somewhere with this, okay? At the top of your paper, if you'd please do this. Just very quickly, and don't look at anybody's paper. This is not a trick question, okay? Do not look at anybody's paper. I want you to write down 10 divided by 2. Don't look at anybody's paper. Write down 10 divided by 2. We all done? Okay. Anybody write that?
Yep.
Okay. Anybody write that? You say yeah?
What is it?
No? Anybody write this? You did? Anybody write this? What are you laughing at? Ain't nothing wrong with that. Anybody write that? Who's right? Everybody's right, okay? Everybody's right. What I'm getting at is there's different ways you can write that, okay? So what I want you to understand is this. The cube root of 8 to the first, and again, I'm going to do like 4 or 5 of these, okay? I don't want you writing them all down, and then when you're all done, like, I don't get what he did here, okay? I'll give you time. It's not going to take you long at all to jot these down, okay? Another way of saying the cube root of 8 to the first is 8 to the 1/3 power. It's the same thing, okay? It's the same thing. Radical 25, okay? What number that we don't normally put there is there? We just don't normally put it. If it's a square root, we put a what? What could we
2.
put? A 2. And what's 25's exponent?
1.
1. That's the same as 25 to the half power. Now, if I give you this right here, radical 100. Again, what number's sitting right here?
2.
2, and this is a 1.
So it'd be 100.
100 to the half power. Now, be careful. What is radical 100?
So that's
10.
6.
10. Students see this, you know what they think all the time? They think 50. It's not saying take half of it. You need to understand that the square root of 100 is the same as 100 to the, it's the same thing. 100 to the half power is the same as a square root. Now, if I give you this right here, the cube root of 27. 27 is to the first power. That's the same as 27 to the what power? 1/3 power. Now, I'm going to show you how I remember this. I'm going to give you some that you may not know. I mean, these ones you should know. What is the cube root of 8? No, what is the cube root of 8? What do you times by yourself 3 times to get 8? So 8 to the 1/3 is 2. It is 2. 25 to the half is 5. 100 to the half is 10. What's 27 to the 1/3? It's not 9. Careful. It's 3. Why? 3 times 3 times 3. This is 3. Okay.
So that's 64.
So you don't need to put all, well, go ahead and jot these down. We got it, yeah, you don't need, I mean, jot down what you think, I mean, if you have one or two of them and you think you got it, don't, write down what you want. We're gonna do a couple more here in a second. While you're writing them down, I want you to understand is this. You can write things with radicals, or you can write them with fractional exponents, okay? They're both okay. And what I tell students is this. If you're not sure, tell me to move if I'm in the way, okay? I'm not gonna take offense. If you're not sure what the answer is, well, I'm gonna say this probably 50 times over the next couple weeks or so, okay? If you don't know an answer to something, rewrite it. If it's written without radicals, write it with radicals. If it's written with radicals, you know the answer, write it without radicals. Okay, rewrite it, okay? So, based on what I just said, somebody have the guts to speak up. What's 64 to the 1/6 power?
Wait, 3?
Okay, slow down, hang on, these are going faster than me. Well, how'd you get 2 so quickly? Who said 2? How'd you do that so
2
quickly?
times 6. Yeah, or 2 6 times.
Okay. You guys are going too fast for me. I guess I got to speed up, okay? I was hoping you were going to say, I don't know. So let's rewrite this, okay? Let's rewrite this, okay? So it's the 6th root of 64 to the 1st power. The 64 to the, or the 6th root of 64 to the 1st. Now, the answer is 2, because 2 times 2 times 2 times 2 times 2 times 2. Now again, some students say, oh, it's 12. It's not 2 times 6. It's 2 times 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. Times 2 is 64. Is it now is negative 2 times negative 2 times negative 2 times it is 64, but we want the positive 6th root. So it's just 2. Okay? Now, let's jot down like 2 more examples, then we're going to move on. If I give you this right here, 25 to the 3/2 power.
So it'd be 2, 25, 3.
Okay, he said it. He didn't say it the right. I know what he meant. Perfect.
Is that right?
Okay, you didn't say it mathematically. No, you tell me what to write.
25.
No, that's not what you said first.
2.
2, then the radical, 25 to the 3. Okay. Now, here's the thing. I'm gonna tell you right now. On your assignment, it's gonna say rewrite this, and it'll have that for a choice, and it'll say this for a choice. Are those the same thing?
No.
No, they're not. Okay. Here's how I remember it. Okay. I don't care how you remember it. This is the way I remember it, though. Okay. When I wrote this, okay, and you're up in a second, okay, Connor. What's the last thing I wrote?
2.
The 2. When you started talking, what's the first thing you said?
2.
The last thing I write, when I rewrite it, is going to be the first thing you write. So, what's 47 to the 9/8 power the same as?
8.
8,
Radical.
radical,
And then
47.
And 9.
I have absolutely no idea what that is, okay? But whatever's last is first. So let's work backwards. How would I rewrite the cube root of 15 to the 4th? 15 to the, is it going to be to the 3/4 or 4/3?
3 over 4. No, 4 over 3.
Which is it, 3/4 or 4/3?
4 over 3.
Why is it 4/3?
Because 4 is the last. 4 is the last thing you wrote.
Well, it wasn't the first thing you wrote over here. The first thing I wrote over here was 3. So over here it's got to be last, okay? First is last is first. Now we're sitting there going, I don't quite get it. It's okay, we're going to do a lot more problems and you'll get it eventually, okay? All right, so if you want to jot those down, I would jot, those couple examples down. Okay. Okay. Now, those of you who are going way too fast, please slow down and answer the way I want you to. Good for you, I'm just giving you a hard time, okay? I'm looking for a specific response right here.
I don't know.
What? That's what I want to hear. Thank you. I always know. You never know what's going on, so I can always count on you guys. Yeah, I don't know what 25 to the 3/2 power is. So what do we do?
Rewrite it.
Rewrite it. The
So
what?
the-
Root of what?
2,
2.
25, and 3.
Now, and you're going to write it just like that. The way I want, and I'm not going to yell at you for this, but the way you should say it is, we don't say like the 2 root, we say the what root?
Cubed.
Now the cube root, the square root of 25 cubed. This right here, how would I say this? The 6th root of 64 to the 1st, or just 6th root of 64, okay? All right, now here's the deal. What do we do first? Do we either do the square root of 25 or 25 cubed first? Guess what? It doesn't matter. But usually one of them's easier than the other, okay? Do you guys know what 25 cubed is? You know what 25 times 25, don't say 75. Not 25 times 3, 25 times 25 times 25.
25 squared is easy.
What's that?
It's squared is easy.
I still hear you said.
Squared is easy.
Yes, it is, because why? I mean, what is 25? Say it. Come on, this is you. What's 25 times 25 times 25?
I don't know.
You don't know either, okay? But you should know the square root of 25. It's what? 5. Are we all done then?
No.
5 what?
To the second.
That's in the second.
No. Third.
5 to the third. And what's 5? This one you should know. 5 times 5 times 5. 5 times 5 is 25. What's 25 times 5? What's 5 quarters?
100.
5 quarters.
125.
125. If you don't know the answer, rewrite it. Usually one way is easier than the other. Negative 243 to the 1/5. Negative 243 to the 1/5 power. What's the answer? Me neither. So let's rewrite it. The what root of what?
The 5th.
Why did I write 5 first? Why did I write that
It's the
first?
last thing you wrote.
It's the last thing I wrote. The last thing I wrote was 5, so it's the first thing I wrote. The 5th root of
243.
negative 243 to the first. You don't need that one. I mean, negative 243 to the first is negative 243. The 5th, can I take the 5th root of negative 243? Can I do that?
No. Yeah.
Yes, we can. We can take the odd roots of negatives. What we can't do is take an even root of a negative. Okay? So, what times itself? 5 times. Could it possibly be 2?
Possibly.
No. What do you get when you keep timesing a bunch of even numbers together?
Even.
And I want an odd, so it's got to be, could it possibly be 3?
It's either 5, 7. Could possibly be 3.
Could it be 3?
Yeah.
What do you want to try first? 5, 7, 9, or 3?
5.
I would try 3 first. Why?
Because you're timesing it 5 times.
Yeah. Why would I try 3 first, though?
Glass
It's smaller. It's easier. I mean, can we try 19?
Yeah.
What's 19 times 19? You want to do that on paper?
No.
Me neither. Let's try 3. You can do most of this yet. 3 times 3 times 3 times 3 times 3. What's 3 times 3? 9. This is another 9. What's 9 times 9?
81.
81 times, what's this over here? These are all what? 3s. 81 times 3 is 243. So what's the answer 3?
Yeah.
Negative 3.
Negative 3.
No, I mean, if you know your times tables. If you don't, I'm not saying you can't do this without knowing your times tables, but it's tougher. Okay, 17. 8 to the negative 2/3 power. Okay, we have a negative exponent. Okay?
I don't know.
If you remember, negative exponents, okay? Just put this on hold for a second here. 5 to the second is 25. 5 to the negative second is not negative 25. It's 1 over 5 to the second. So it's not negative 25, it's 1 over 25. If I gave you 4 to the negative second, that's the same as 1 over 4 to the second, so 1 over 16. Okay? So let's rewrite 8 to the negative 2/3. That's the same as 1 over 8 to the 2/3. What's 8 to the 2/3? Me neither. So what do?
You rewrite it.
Rewrite it. How do I rewrite 8 to the 2/3 power?
2.
2, the first thing I write?
3.
Which is it, 2 or 3?
3.
How come 3?
That's the last thing you
The
wrote.
last thing I wrote was 3, so it's the first thing I write here. So the cube root of what?
8.
8
And then 2.
squared. And there's a 1 on top still. Now in this case, you should be able to do either one of them pretty easily. You should know the cube. By now, we've done this a couple times today, 2 or 3 times today. What's the cube root of 8? 2 squared is 4. How about if we do this? What's 8 squared? 64. What's the cube root of 64? 4. Why? 4 times 4 times 4 is 64. So what should I do first? The cube root of 8 and then square it, or 8 squared and then cube root it?
Whatever's
It doesn't, in this case, you should be able to do both, okay? This right here is 2 squared. So is the answer 4? Not 4. Where's that 4 at? Under what?
1.
So it's not 4, it's
1 over.
1 over 4. Okay, 21. Okay, we got to knock these out. These ones are the easy ones now. And again, you got to be careful on these. They're very easy. They're also very easy to mess up on, okay? What does that say? The third root of 5 to 4. All I want you to do is rewrite it. That's all I want you to do. Rewrite the cube root of 5 to the 4th. Write it without radicals. So 5 to the what?
4.
4?
No.
Just 4?
3 over.
4 over 3.
Okay, is it 3 over 4 or 4 over 3?
4 over 3.
Why is it 4 over 3?
Because 4 is the last thing you wrote.
3 is the first thing I wrote, so it's going to be the.
Wow.
That problem's
Got
done.
it.
Whatever's first is last.
That's right.
Ain't first, you're last.
Okay.
I like that.
Number 23. Rewriting this one also. 1 over the 4th root of 5. Okay. 1 over the 4th root of 5.
So
What's the exponent on 5? I don't see it. It's a 1.
1.
1. Just ignore this 1 right here, okay? How would I rewrite the 4th root of 5 to the 1st?
1. What?
How would I rewrite the 4th root of 5 to the 1st? 5 to what power?
5
To
to
the-
the negative 1.
Don't, slow down. Just don't worry about this 1 on top yet. Would it be 4 over 1 or 1 over 4?
1 over 4.
Now, if you look on your computer, that's not a choice. They actually want you to rewrite it not as a fraction. If I move this 5 to the negative, if I take this 5 to the 1/4 on bottom and I bring it to the top, it turns into what? Come on, I said it, half of it. 5 to the what?
Negative.
Negative 1/4. That's what they want you to put.
Can
Okay.
you just say that as, like, can
You're
you
right.
go through that step?
Yeah, but I just don't want to skip steps. I'm not as fast as you, Iobi, okay?
No,
I'll
yeah,
try to
no.
catch up with you, man.
No, hey, appreciate it. I'm saying like that's making.
No, you're right. You're good. That's fine. I'm just messing with you. Shoot, we're almost done with this. We might just have a work day tomorrow and you won't have to do anything on
I
Wednesday.
like that idea.
Okay, 35, 38. We only got 3 more to go. Sweet. Okay, 35. All the way to number 35. After 23, the next one was 24, and then we go right to 35. And tell me the God's honest truth. Don't just tell me what I want to hear. I mean, am I going through this? I don't want to go through this too fast.
Good.
Okay. I mean, once you get this is really easy stuff, but it can be kind of confusing. So, okay, find the real solutions of x to the 3rd is 125. Okay. Now, you better be able to answer this one. We just had a test. This is the easiest question on the test last week. How many answers this thing got? 3. 3 solutions, okay? The highest power is 3. There's 3 answers. They only want the real ones, okay? Now, here's the deal. Put this on hold for a second here. If I give you x squared is 100, okay? What cancels out squares? What would cancel out squaring something? Just like what cancels out adding? Subtracting. What cancels out multiplying? Dividing. What cancels out squaring?
Negative.
No, square rooting. Square rooting, okay? You square root each side. Didn't I show you the proof about girls?
Yes.
I showed you that, didn't I, about girls being evil?
Yeah.
Yeah, you don't remember that? Come on, you gotta remember that. Okay? Squares and square roots cancel each other out. Like if I give you this, you should be able to answer this right now. What's the square root of 17.4 squared? These things destroy each other, so what are you left with?
17.
17.4. What's the square root of 83.6 squared? 83.6. These destroy each other. It's no different than this. If I take 14.7 and I times by 38 and then I divide by 38, you know what you get?
14.7.
14.7. You get back where you started. They just cancel each other out. Okay? All right. So what cancels squaring? Square roots. What gets rid of cubes?
Cube.
No. What gets rid of cubes? You left out a word.
Cube roots.
Cube root. And be careful. Some students go, that's the same thing. No, they're not. They're opposites. They're opposites. If I give you 9, if I ask you to square that, Square it. Not square root it, square it. Square 9. It means you times it by itself, so you get what? 81. Square root it and you get 3. Okay? All right, so the way we get rid of cubes, we cube root each side. Cube root this side, cube root this side. What's the cube root of 125? Heard somebody say it. Why? 5 times 5 times 5. Is it also negative 5?
No.
No. Okay. This problem's done other than I just want somebody to say this. I thought there were 3 answers. That's only one of them.
No.
What are the other 2? One word. They're imaginary.
Oh,
Oh.
But we're not dealing with imaginary numbers in this chapter. 38, next one. Okay, Jordan brought something up a few minutes, about a half hour ago, and we're going to talk about this here, okay? X minus 5 to the 4th. This is probably the toughest part of this section. Oops, x minus 5 to the 4th. This is the hardest part for students to get. X minus 5 to the 4th. How many answers? How many total answers this thing got? 4. Okay, 4 total answers. Because it's 4th power. Okay, they may not all be real though. Okay, so how do I get rid of a 4th power? How do I get rid of a cube root? How do I get rid of cube? Cube root it. How do I get rid of the 4th power? 4th what?
Power.
I have a 4th power.
Fourth
Fourth root it. How do I get rid of a 5th power?
Fifth.
5th root it. This is where you got to be careful on this, okay? When you take an even root of a number, when you take an odd root of a number, you said this earlier. You asked me what? If you have an odd root, you have how many answers? No, how many answers? You said, didn't you?
Oh, 1.
You only have 1. We took an odd root. How many answers do we have here? Only 1, okay? We're going to take a 4th root. Are we going to get only 1 answer?
2.
Why? It's an even root. We're going to get 2 answers. We're going to get 2 answers here. And we can't have 1 answer. If you guys can remember this, we haven't talked about this in about 2 weeks. There's no way there's 4 answers that you're going to have exactly 1 real answer. Why? If you have 4 answers and 1's real, there must be what?
1.
No, if one of them's real and there's 4 total answers, there must be 3 that are imaginary. What's wrong with that? They come in pairs, okay? All right, so let's 4th root this. 4th root here, 4th root here. And Jordan just said that we're going to get 2 answers here, okay? The 4th root of 256. What number times itself 4 times is going to give you 256? Maybe 3? Could it possibly be 3? 3 times 3 times 3 times 3 is going to be what kind of a number? It's going to be an odd number, okay? Maybe 4? You think it's 4? 4 times 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. And negative 4?
No.
No.
Just 4.
What's negative 4?
No,
How many answers are we going to get?
2, yeah.
2.
Yeah, it cancels it
So
out.
4 and negative 4. Now hang on, we're not done yet. These cancel, so what's on the left? These destroy each other. What's on the left-hand side?
X minus.
X minus 5 equals what? What's this?
2.
No, not 2. That's not what we said. There's 2 answers. What are they?
4 negative.
4 or negative 4. What's the last thing we have to do? Want to get x all by itself?
Add 5.
Add 5. So add 5 here, add 5 here, and add 5 here. So x equals what?
Are we adding?
9 or not negative 9. Careful.
1.
1. Which is it, 9 or 1?
Both.
You might want to make a note to yourself here. When you take an even, this is what Jordan brought up a half hour ago. When you take an odd root, 1 answer, 1 real answer. When you take an even root, 2. Okay, last one. That was 38.
So it's 9.
All right, 38, 43. Now, I will tell you this. The computer's nice because when you're clicking on these, it has 2 boxes. What does that tell you?
2 answers.
2 answers. On your written test that you'll take in a month, you're going to have little boxes there to fill in. It's just going to say, give me the answers. No, nope, I'm mean. All right, last one, 43.